Hello dear friends, welcome to Byjus Exam Prep and I welcome all for this particular Super 11 series, and in this session I am going to discuss the Super 11 questions of Discrete Mathematics. Hope you are all ready for the session. Hello dear friends, am I audible? Hi, good morning sir, very good morning. Yeah, Satya, very good morning. Hopefully I am audible to all of you. Welcome to the session. Okay, hope you are not having the notification for this session. And this is about me, myself, Sridhar Dhulipala. Hi sir, good morning, very good morning. Welcome to the session. So myself, Sridhar Dhulipala, I am having 20 plus years of teaching experience and my qualifications are MTech from NIT Karnataka, Surathkal and MSc Mathematics. I am associated with Byjus from past 2 years and I recorded all these subjects, engineering mathematics for all branches and for computer science students, discrete mathematics, C programming, data structures and algorithms were recorded by me. You can find all these recorded GATE content, first of its kind, under BYJU'S Exam Prep app in the category name Learn with Video Lessons. Okay, there you can find all these video lectures which were recorded by me, my dear friends. So with BYJU'S you are having double advantage. And there's a mega workshop today at 12:30 by Rakesh Thalreja sir. You can attend that immediately after this session. Okay, hopefully our session will be completed by that time and you can immediately join that. Okay sir, we'll see that sir. Okay, now there is Super 11 series going on for all the branches. Okay, EC, EE and IN and CS, my dear friends. Acha, A to power set of A. See my dear friends, it is not a 1 1 function because number of elements are not same, then it cannot be 1 1. Okay, that happens for infinite set when you talk about countability and all. Okay, otherwise no, right? No mapping, no, there is no 1 1 mapping for them. A and power set of A, no. And tomorrow top 11 engineering mathematics and general aptitude questions. So this session is conducted by 4 of us, Ankit Joshi sir, Ashutosh sir, Rakesh sir and me. So I'll be discussing around 25-26 problems in engineering mathematics. Tomorrow it is starting at 10 a.m. sir. The starting time of this particular session is at 10 a.m. my dear friends. See, I don't know. See, the problem, many people come up with some questions given in some books. Without understanding context, you cannot answer the questions. Deepak Prasad, see, I am not responsible for every question given in the world. Okay, please don't make me responsible for every question and every answer of discrete mathematics. If someone given, you need to understand the context under which it is given. What is set A? Without knowing that, you cannot comment on such questions. Am I clear? Suppose if it happens in test series, you please ask the people who given that particular question. Am I clear? If it is given in a standard book, okay, or a standard result, I can talk about it. Now you keep on asking every question in the world, whatever comes, someone asks some idiotic question. If you ask me, I cannot answer that. Okay, so if it is in the book, send me in the Telegram group. I'll go through that particular question, context, then I can answer you. Am I clear? See, that Cantor theorem is a diagonalization part. That is a different story, my dear friends. That's what I already mentioned. If it is for infinite set, there is something called set to that particular 1 1 mapping is created by creating a function. That particular function need to be created. Okay, you generally ask A to power set, that is not a 1 1 function. I directly denied that. Now you are saying Cantor theorem. So Cantor theorem is to prove that set of rational numbers are countable. Set of rational numbers are countable. To prove that, it is used. So without using the context, without knowing the context, you generally pose a particular question, it would be meaningless question. So send me from which book you got that particular information, okay, so that I can tell you in what sense they given that particular one. Questions are always based on the context. Even if you see GATE questions, they always give you context and ask you the question. Remember that. So this is at 10 a.m. So let us start with the Super 11 question, the first question. Please answer the question. Please answer the question, my dear friends. I'll give you 2 to 3 minutes for each problem. For this 2 minutes time, I'm going to give you based on the complexity of the problem. Yeah, answer the question. One minute more. See, for this PDF will not be provided, only no PDF, nothing will be provided, sir. You have to attend the class and get the questions. Only 11 questions, for that don't expect any PDF. Okay, so no PDF will be provided for this. Remember that. Solutions will be discussed. Okay, you need to have patience for 11 questions, 11, 1 hour maximum. So if no one is answering, I'll just go with the solutions of this, my dear friends. No issue. See, we are having 52 chairs in which 49 people are sitting. Means 3 chairs are vacant. There are 3 chairs which are vacant. So remaining people are sitting in the chairs in these gaps. That is, okay, 1, 2, 3, 4. 4 gaps are there. In that 4 gaps, 49 chairs are there, 49 people are sitting. Now we need to answer, okay, at least how many set of consecutive chairs are always filled with people. At least how many, because there is a vacant seat, this is an empty seat, this is empty seat, this is empty seat, this is empty seat. So these are the consecutive chairs, these are the consecutive chairs, these are the consecutive ones, these are the consecutive ones. So what is the minimum number of consecutive chairs that are always filled with people? Any answers for this? See, these are super 11 questions, and when I make super 11 means they are very, very important questions, my dear friends, and created by me. So now 49 people, these are like 4 pigeonholes. These are like 4 pigeonholes. Okay, if you are having 49 members and 4 pigeonholes, at least how many are in the same pigeonhole? That is a question. Okay, so we are having 49 people. These are like pigeons, and 4 consecutive chairs or 4 sets of consecutive chairs. Very good, Kaustubh. So these are like pigeonholes. So at least how many? The at least number is given by 49 by 4, seal of it, which is 12 point something, that is 13. So option C is the correct answer for this. Option C is the correct answer for this, my dear friends. Okay, good question to start with. The next one. Second question on your screen. Second question on your screen. B. Dipyan Datta says B. Hmm? So we are having 4 boys and 4 girls, okay, arranged in a row such that in a such a way that exactly 3 girls are together. See, generally when you are having 4 girls, the different possibilities would be all the 4 girls may be together, 3 of them together and 1 separate, 2 together, 2 together. This is first possibility, second possibility, third possibility. 2 together, 1 together, 1 together, and all the 4 separately, my dear friends. So these are the possibilities, my dear friends, when you are having 4 girls. So here you want this particular category. See, whenever you want to answer this particular category, you need to know number of partitions of each type. Number of partitions of each type, when you know, then you can answer this question better, my dear friends. So we have only one such partition, we have 4 such partitions, and such partitions we have, how many such partitions we are having, sir? We are having 3 such partitions, and such type of partitions we are having 6, and this type of partition we have only 1. So the question about this fellow, so we should know how many such partitions are there. See, first of all, boys are not having any condition. Arrange 4 boys. See, 4 boys can be arranged in 4 factorial ways. 4 boys in a row can be arranged in 4 factorial way. First we arrange them. It's not a bell number. The total sum is bell number, sir. Total sum is bell number, but individual values are not bell numbers. Programming wala. Okay. So this 4 factorial ways. Following this, now look here. There will be 5 gaps. When 4 boys are arranged, there will be 5 gaps. There will be 1, 2, 3, 4, 5 gaps. In the 5 gaps, you have to arrange this and this. That is 2 patterns, 2 fellows you have to arrange. That is this pattern and this pattern. So in 5 gaps, you have to arrange 2 patterns. But how many such 2 patterns are there? How many such 2 patterns are there? There are 4 such 2 patterns. After arranging it, because you arrange 3 together in one what do you call, one block or one gap, but the 3 fellows can be arranged among themselves in 3 factorial ways. Again, this one fellow can be arranged among themselves in 1 factorial ways. So the answer for this problem would be this one, my dear friends. So this is the total answer for this problem. Number of ways boys can be arranged, number of ways the 3 and 1 parts arranged in 5 gaps, okay, then followed by number of partitions of type 3 and 1, and this is number of ways the 3 girls who are together can be arranged among themselves. Number of arrangements of 3 girls. And this is number of arrangement of 1 girl. So when you simplify, you get the required answer. I think the answer is 11520, which is option C, my dear friends. Which is option C, my dear friends. See, for some of these questions, you will not find solutions even in the market. So, see, 5 gaps are there. Now, 5 gaps you have to fill these 2 types. These 2 types you have to fill in 5 gaps. Because the 3 together are like 1 unit. 2 units, these are 2 units. One is 3 and one is 1. These 2 units to be arranged in 5 gaps. 2 units in 5 gaps, how many ways you can arrange? 5p2 ways. That is the idea. The next question. Next question. See, I am repeating, no PDF will be shared for this. You have to see all the 11 questions here only. No PDF will be shared. Super 11 questions will not be shared anywhere, my dear friends. Please share, subscribe and like this session. The questions are very, very interesting, created by me, my dear friends. Will be very, very useful for your examinations. Even regular students also. For everyone it would be very, very useful for sure. Number of ways 3 zeros, 3 ones and 3 twos can be arranged so that no 3 adjacent digits are same in the arrangement. So we are having 3 zeros, 3 ones and 3 twos. Okay, you want to arrange them in a row. How many arrangements are there in which no 3 adjacent digits are same? No 3 adjacent digits are same. I'll give you hint. Inclusion-exclusion principle. Inclusion-exclusion principle. It's a numerical answer type. Please answer this question. Only for first question I seen people answering, like Kaustubh Nageshwar answered. Again for second question no one answered correctly. I need to give the answer. Third one, let us see. So let us see for how many questions you can answer. Okay, in 3 minutes time. So I given the hint, no one used the hint for this problem. Let us solve this problem. 324 less number, sir. 324 is less for this problem, programming wala. No. So let us make the options so that next time it would be useful for me. What answers people get generally, let us keep them as options. Nice. Okay. Any other options? Just give some answers so that we can fill the options A, B, C. I can fill the options A, B, C kind of. Right. See, my dear friends, let us call set A as the ones in which 3 zeros together. So, A is the set in which 3 zeros are together. Oh, Deepyan Datta, super. 1314 option B. Deepyan Datta with answer 1314. Very good. Any other options? B is ready. Any other options? Deepyan, you answered previous question also. I think you answered wrongly previous one. Okay, no problem. Your lucky number is B. Deepyan. Nice. So let us call A as 3 zeros together. B is the set in which 3 ones together. C is the set in which 3 twos together. Now what is that you want? No 3 digits together. That is, no 3 adjacent digits are the same. So you want A complement, B complement and C complement. So what is that you want? A complement and B complement and C complement. That is nothing but number of elements, total number of elements minus number of elements in A plus number of elements in B plus number of elements in C minus A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. So this is the idea, my dear friends. So first of all, what is total here? Total means number of arrangements of the 3 zeros, 3 ones and 3 twos. That is total. So total is number of arrangements in which total 9 digits are there, in which 3 are same zeros, 3 are same ones, 3 are same, that is twos. This is total, sir. So this total is 9 factorial by 3 factorial, 3 factorial and 3 factorial. So what is this answer, my dear friends? Can someone please tell me what is that? Please tell me what is that answer? See, here we need to understand the symmetry. The number of elements in A and number of elements in B and number of elements in C will be same. Story is same, na? So if you can find one, these three are same actually. So you can simply do this some value, you get it. Please tell what is this answer? 9 factorial by 3 factorial into 3 factorial into 3 factorial. I want this solution, sir. 1680, very good. Dinesh Teja, 1680 is this number. So let me put this also as one option for future use. Okay. Now here A means 3 zeros together. That is 3 zeros are like 1 unit. Remaining 6, 7 units you are having. 7 units can be arranged in how many ways, sir? 7 units in which 3 are same, 3 are same, but the block of 3 zeros is 1. So this can be arranged in 7 factorial by 3 factorial into 3 factorial into 1 factorial. The story is same for B and number of elements in C also. The story is same for number of elements in B and number of elements in C also, my dear friends. Story is same. Now next comes 2 combination, that is A intersection B. See whether you take A intersection B, A intersection C, yeah, B intersection C, the story will be same. Because here you want AB means 3 zeros together and 3 ones together. 3 zeros are like 1 unit, 3 ones are like 1 unit. Remaining how many? 3. 3 plus 1 plus 1, 5 units. So 5 factorial in which 3 are same, that is 3 in which 3 are same. What are they? They are 3 twos. and remaining, because zeros are kept together, that is 1 unit, ones are kept together, that is 1 unit, but that can be arranged only in one way. So it is 1 factorial into 1 factorial. So this answer is same for these two fellows also, my dear friends. The two combinations will be same. So please tell me what is this answer. Can someone tell me what is the answer for 7 factorial by 3 factorial into 3 factorial? Because the answer is same for all the three. The answer is same for all the three. Can someone simplify and tell me this answer quickly? Very good. No answer. So this would be 3 into 7 factorial by 3 factorial into 3 factorial, and here these are same 3 times. So 3 into 5 factorial by 3 factorial, my dear friends. So that is 140. Yeah? Okay, this is 140. So is this. So is this. I don't know these answers are correct. Please wait. Achha, is it 1080? Is it 1080? What is this answer, sir? Arey yaar, why you are making so much confusion? 7 into 6 into 5 into 4. 1 3 factorial cancels, one more 3 factorial will be there. 7 5s, 5 4s 20, 140 is the answer. How much time it takes for you? Okay, okay. This is 140. This would be 5 factorial. 5 into 4, 20. This also will be 20. This also will be 20. So this answer would be 3 into. So I'll directly write this way only so that you can remember the logic. 7 factorial by 3 factorial into 3 factorial. Next, 3 zeros together, 3 ones together, 3 twos together. That is 1 1 1, 3 units. So 3 units can be arranged in how many ways? 3 factorial ways. So that would be the answer, my dear friends. That is the total answer. The simplified answer is Dipyan Datta given correct answer only. Yeah, that is 3 factorial only. Dipyan Datta given correct answer only. This would be 1314 is the correct answer for this. 1314 is the correct answer. Dipyan correct. So out of 3 questions which I asked, for 2 people could able to answer, for 1 people not answered. Very good. Let us see the remaining one. Is the logic clear, Babu? See, when it is A intersection B intersection C, this would be 3 factorial. Yes, total answer is 1314. Ravi Gaming. Total answer is 1314. Yes. Perfect. Super. अगला समस्या on your screen. Next question. So let us start 3 minutes for this. It is 11:29. So 3 minutes from now. 11:32, I'll answer the question. Till that time you can try this. Of course, simple technique also you can use it. First understand the question, then answer this. I repeat, this PDF will not be shared. One minute more for this question. 30 seconds. Problems from recurrence relations. This type of problems were asked earlier also in GATE. So possibility is there for this type of question in GATE again. I generally don't say that I expect this question kind of things. I don't expect anything. I'll go with open mind for the examination. Okay. So generally when people ask me like what is your expectation, I don't expect anything. That is the best thing you can do for your examination. Go with open mind. Don't expect anything. Expect the unexpected. That is the best methodology for preparation. Don't expect. Respect the paper, answer the questions. Now let us see the answer for this problem. See my dear friend, a computer system considers a string of quaternary digits. Quaternary digits means 0, 1, 2, 3. This is called quaternary digit. Okay. Deepak Prasad has one answer, very good. And he says that this string of quaternary digits is a valid code word if it contains an even number of zeros. If it contains an even number of 0 digits, then it is valid. For example, he given this. You see, this is a string of quaternary digits. It is having 2 zeros. Therefore, it is valid. Whereas this fellow is containing 3 zeros. Therefore, not valid. Now, suppose if an is number of valid n digit code words. Okay. The recurrence relation for an is what? What is the recurrence relation for an? See my dear friends, I'll tell you the methodology we can follow for GATE examination. Okay, if you are interested, I'll tell you the general way of writing recurrence relation also. But generally people are interested in this first method. So let us see. See my dear friends, how many one digit quaternary numbers are there which does not contain, which contain even number? We want contain, which contains even number of zeros. See, one digit numbers are 0, 1, 2, 3. This contain odd number of zeros, so there will be A1 is 3 my dear friends. A1 will be 3. Now what about A2 my dear friends? A2. See, actually if you consider 2 digit numbers, there will be totally 4 possibilities here, 4 possibility here, 16 possibilities are there. Out of that, what is that he is asking? Even number of zeros he want. See, if zeros are 0, that is also even. If zeros are 0, that is also even. So from this 16, you have to subtract where you are getting odd number of zeros. Odd number of 0 means one place you get 0, other place you get non-zero number. That is 1, 2, 3. That is one possibility. That is 0 here, 1, 2, 3 here. Yeah, 1, 2, 3 here, 0 here. So these are the 6 numbers which are having odd number of zeros. So out of 16, 16 minus 6 means 10 fellows will be having odd number of zeros. 10 fellow. A2 is 10. Now please verify which one satisfies this particular in your problem. Which one satisfies this particular? Why? Maybe sir, you can check that now, because A1 is 3 fixed, A2 is 10 fixed. Suppose if more than one satisfies that, then you have to go for A3 also with this method. This is called verification method. This is the verification method. Is the idea clear? So let us try this A option. What is A2? A1 is 3 plus 4 power 2 minus 1. 2 minus 1 is 4 power 1, which is 7, which is wrong option. A2, 3 into A1 plus 4. 3 3 is 9, 9 plus 4 13. This is wrong option. A2, 2 into 3 plus 4, which is 10. It may be correct option. Now let us try the last one. If it fails, then C is the answer. A2, A3, that is A1 is 3 plus 4 power n minus 2. N minus 2 means it becomes 4 power 0, that is 4. That is why it is wrong. So only C is the correct answer, my dear friends. Only C is the correct answer. Like that. Hope you understand. So this is how we can answer such questions very easily, my dear friends. This is the method where you can verify. your recurrence relation. Of course, you can also generate the recurrence relation, but I think you understand this technique. You like this technique for, see, this is a good technique, but it may fail with A2, then you have to go for A3 also. Then you have to go for A3 also. The next question. The next question. Yeah, you can apply easy methods only, no problem. Satya, follow it. But writing recurrence is very important actually in GATE, that you should see. This is a simple one. I think most of you should answer this. Sometimes the question may be combined with probability also. What is the answer? 1/8, Subrajit. See, a relation is selected at random from a set having 3 elements. So, number of relations, the number of relations would be 2 power 3 square, that is 2 power 9, yani 512. What is the probability that a relation selected at random is neither reflexive nor symmetric? Neither reflexive nor symmetric. Dipyan Datta also says 1/8. Why people are saying 1/8? Let us see. See, neither reflexive nor symmetric. Now let us see number of symmetric. Let us call set A as symmetric, number of symmetric relations. You know how many symmetric relations are there? 2 power n into n plus 1 by 2. That is through 2 power 3 into 3 plus 1 by 2. Correct or not? This is number of number of symmetric relations. That is 2 power 6. Number of reflexive relations, 2 power n into n minus 1. That would be 2 power 6 again. What about symmetric and reflexive? Symmetric and reflexive, how many will be there? How many relations are symmetric and reflexive? Yeah, 64 in both the case. How many are symmetric and reflexive? Symmetric and reflexive means, see, once it is reflexive means all that numbers must be 1 1 1, but because the reflexive elements must be selected. So it is given by the formula 2 power n into n minus 1 by 2. That is 2 power 3 into 3 minus 1 by 2. Yani it is 2 power 3, which is nothing but 8. So neither reflexive nor symmetric means this is what you want. This is neither. Am I clear? So when you want probability of this, when you want probability of A complement intersection B complement, it is 1 minus probability of A union B, which is 1 minus probability of A union B, denominator 2 power 9, numerator 2 power 6, 2 power 6 minus 2 power 3. That would be the answer. So which is nothing but 1 minus, this is 512, this is 64, this is 64, and this is minus 8. That is 120 by 512. So what is this? Correct only, na? 512. 512 minus 512 minus 120. What is 512 minus 120? Actually, this would be, I think I given the options wrongly, I think. Yeah, I made some mishap with the options, sorry. Okay, yeah. That is 1 minus 15 by 64 it is, which is nothing but 64 minus 15, 54, 49 by 64. So my options were wrong, I miscalculated. Somewhere I have to give something like this. 49 by 64. I miscalculate, sorry. Yeah, sorry, my question is wrong. I mean, options were wrong. Of course, if such thing happens, you all get marks, my dear friends, don't worry. But it's not like we cannot solve it. I given wrong question, wrong answer for this, because I never calculate completely. Yeah. So that is 49 by 64, na? Right? 49 by 64. Now I changed the options. D is the correct answer. Sorry for that. Yeah. Now let us see how many more mistakes I done today. The next question, sixth one. Which of the following is not valid? No. I think it's not MSQ, it's not valid. Which one is not valid? Hopefully I made one. I made only one invalid. It's not MSQ. MSQ it will be mentioned. I know mostly you use your truth table methods. So let us see option A. It's like negation P or negation Q implies R or S. Next, R implies T, negation T, therefore P. Yeah. See, my dear friends, here if you observe the last one, R implies T and negation T, can give you negation R. So this is one thing you can get it. Second thing we can get it is from negation R you can do addition property. You can add anything. I add negation S because I have this R or S. So that I think it is R and S. I'm sorry. Please be careful. It is R and S, right? So I just add, this is addition property. Now if you observe, this is nothing but negation of R and S by De Morgan's principle. Now the next step which I do is, here we are having negation P or negation Q implies R and S, and I have negation of R and S. Again modus tollens will give you negation of negation P or negation Q, which is nothing but P and Q. De Morgan's property. From P and Q I can get P by simplification. So this is valid, my dear friends. This is valid, my dear friends. B is invalid. I said which one is not valid? B invalid. Let us check option B. Why it is going invalid? Negation P implies Q, Q implies R, and negation R. See my dear friends, it is very clear that negation P implies Q and Q implies R will give you negation P implies R. And you have negation R, by modus tollens you get negation of negation P, which is P valid. It is valid, na? It is also valid, na? Very simple one. First one is little extra work, but this is simple, na? Why it is invalid? Truth table method is giving you invalid answer. Let us check by truth table method. Negation P implies Q and Q implies R and negation R implies P. The variables involved are P, Q, R. Make it false. Try to make this true. You have to make every fellow true. If it is successful, then it is not valid. If you are not successful, then it is invalid. Here P is taken as false. When P is taken as false, negation P will be true. So true implies you cannot have false, because if it is true implies false, it becomes false. So you want it to be true means you have to make Q true. Now Q true means you have to make R true. But R true means negation R cannot be true. So it is valid. So B is valid, my dear friends. B is valid. What about C? Let us see. Let us see C. So here S implies R, R and S implies P or T, Q implies S and negation T, therefore Q implies P. Q implies P means negation Q. Even if you can get negation Q also, you are happy. But here, see, sometimes we can use one logical method. Whenever you want to prove Q implies P, you can do one thing. R and S implies P or T, Q implies S, negation T. If you want to prove Q implies P, you can just add Q also in the hypothesis. You can also add Q in the hypothesis, then you can prove P. So if your conclusion is Q implies P, whenever you can add Q in the hypothesis. You can add Q in the hypothesis, my dear friends. For example, you know P implies Q implies R is there. It is like P and Q implies R. You can verify P and Q can imply R or not. So that logic can be used, my dear friends. That logic can be used here. So with this, it can be solved very quickly because Q is here. So Q implies S and Q will give you what? S. Now again S implies R and S will give you R. Now you are having S and R. So S and R can give you S and R or R and S. Whatever way you want, you can write down R and S. So once you have R and S, this R and S implies P or T will give you what? This gives you modus ponens P or T, it will give you. P or T is nothing but negation P implies T. Here we are having negation T given. So by modus ponens it is, modus tollens it is negation of negation P, which is P. So this is also valid. This is also valid. So this is option C valid, my dear friends. So I just used by rules, I verified. So obviously 3 are correct means D must be wrong option. Invalid. You check by truth table method. You can check this by truth table method. P and negation Q, and P implies Q implies R implies negation R. P, Q, R are the variables. So here you can make it false, that is R will be true. In this time you want to make these two fellows true. So how to make these two true, sir? P should be true and negation Q should be true means Q should be false. You can make it true. Now when P is true, R is false. False implies anything is true. So true implies true, true. That is, true implies false is possible. So it can become false. So it is not valid. Am I clear? So it is invalid, my dear friends. So it is invalid. So option D is the correct answer, my dear friends. See, lengthy to execute, you can try by truth table method also, sir. Okay. See, sometimes even in GATE, I purposefully given this, sometimes even in GATE, we get 1 or 2 questions. It's not always in GATE, see, GATE is not all about solving all the questions, sir. GATE is all about, ignoring the questions. Which question to ignore also we should know that. Am I clear? See, don't always think about solving everything. You are writing a competitive examination, my dear friends. It's not your knowledge display. Don't do such things. Suppose it is lengthy, it can be solved. Using truth table method, it can be solved quickly. Hardly each truth table method takes how much time, sir? See, I use truth table method, hardly taken 30 seconds. If you practice well, it can be done in 30 seconds, otherwise 1 minute. Hardly 4 minutes time it will take. 4 minutes is okay, fine. Because for 1 or 2 questions, you can take 4-5 minutes, no problem. Because I always tell this simple rule, my dear friends. In GATE, we are having 65 questions. Even if you can answer 60 questions, आपका फोटो छपेगा कहीं ना कहीं. ओके, टॉप रैंकर का फोटो होगा ना, उसमें छपेगा. So 60, 180 minutes, 60 questions, 3 minutes approximately for each question. 3 minutes approximately for each question. And there are some questions which can be answered directly. At least 10 to 15% questions will be like that. Actually, not 10 to 15, people say around 30% will be like that. Directly, recall type of questions. Okay, so that would be around 30%, but let me make it very simple, 10 to 15% or say 20%. So like that, there are some questions which can be solved within 1 minute, there are some questions which can be solved within 2 minutes. So for some questions you get more time, obviously. So like that, please plan like that. See, why people fail in GATE examination, many people complain that sir, time is not sufficient, because they take one such problem, they'll spend half an hour for that. If you spend half an hour for any problem, you cannot qualify GATE, my dear friends. Take it as my word. Next one. This is MSQ, sir. This is MSQ. Question number 7. And one more thing, when you say option C is lengthy to execute, you can verify D. D is false means you got your answer. Huh? You can ignore C completely in such cases, because it is not MSQ. Simple one you can execute first in that also. That is one more idea. BC. So we have to find negation of this. Negation of for all x there is a y, P and Q implies R. See, I make it simple because if you write P of xy, Q of xy, it would be confusing because obviously P, Q, R all are functions of x and y. So you can simply write like this so that our simplifications would be easier. When you take negation inside, it becomes there exists x, it becomes for all y. Negation of this P and Q implies R. We have one very beautiful rule. Negation of P implies Q is P and negation Q. So this would be there exists x for all y, P and Q and negation R, and that is exactly option C, my dear friend. So if you completely apply that, that is the answer. That would be the answer, my dear friends. Am I clear? That would be the answer, my dear friends. Now we have this exportation law. If you know this exportation law, it says P and Q implies R is nothing but P implies Q implies R. You all know this rule called exportation property. So here, this particular one, if you observe here, this can be written as there exists x for all y, negation P implies Q implies R, and that is exactly your option B. So B is correct. Very well, nicely identified, Mr. Vengidesh. Now if you observe this particular fellow, what is negation of P implies negation Q? What is negation of P implies negation Q? This is same as P and negation P and Q. This is same as P and Q. So this fellow is same as this fellow. This is another way of writing this fellow. So this is another way of writing this fellow. Same answer. There exists x for all y. There exists x for all y. So A is also correct. A, B, C are correct options. D is wrong option. D is wrong option, my dear friends. A, B, C are correct and D is wrong answer, my dear friends. Of course, this type of things require little observation. Entire logic require the observation, my dear friends. Hope you understand. So actually this P and Q can be written as negation of P implies negation Q. That is the logic used there, my dear friends. That is the logic which was used there. So A, B, C are correct. D is the wrong option. Very nice. Question number 8. Question number 8. Super, super Ravi Gaming. Satya. So I'll just give you the same thing here so that we can work out. So you have to identify A mapped to what, B mapped to what, C mapped to what, D mapped to what, then you can go for options. ये ऑप्शन है. Somebody loves everybody. See, my dear friends, I always tell this. When you have x quantifier first and y quantifier next, it says everybody loves somebody. Here it is x in terms of y. But if you get y quantifier first and x quantifier next, then you are saying y in terms of x. Always remember this. Somebody loves everybody is wrong. This is wrong, my dear friends. This is wrong. It actually says, you know what it says? Somebody loved by everyone. It is not somebody loves. It says somebody loved by everyone. That is, there is someone whom everybody loves. So this is the option for this. This is D. D is 2. So this is what you are saying. Somebody. Okay, even this one, I think somebody loves. Yeah, somebody loves everyone. This is option, this one. So A4 and D2. A4, D2 matching in which options? A4, D2 in two options. So again we are in problem because these two options are wrong. A4, D2 are fine. Now next one is, see my dear friend, everybody loves somebody. Everybody loves. Actually, if you see this negation, if you remove this negation, what happens? For all x, there is a y, L of xy. So everybody loves somebody. That is what, everybody loves somebody. So B goes to 1. B goes to 1 is wrong here. So this is correct. So obviously D is the correct answer. D is the correct answer for this, my dear friends. C and 3 are one and the same. See here, somebody loves everybody is this one. Somebody whom everyone loves, or somebody loved by everyone. Somebody loved by everyone or everybody. Somebody loved by everybody. So this is somebody loved by everybody. Then this one, everybody, that is B is 1, because by taking negation you directly get it. And last one, there is someone whom no one loves. Actually, when you take this negation in the 3, negation for all x, there is a, for all y, sorry, there is a x, L of xy when you have. When you take negation here, you get there is a y, negation there is x, L of xy. So somebody whom no one loves. See, negation of there exists x is no one. Somebody loved by no one. Somebody loved by no one. That is somebody, there is somebody whom no one loves. There is somebody whom no one loves. There is somebody whom no one loves. So this is the one. So this is the idea for this, my dear friends. So simple observation can give you the answer for this. So that is your 8th question. Question number 9. 3 more questions to go. 3 more questions. And these 3 questions are from graph theory. I only taken only logical questions instead of taking other questions like verification type of question. Mostly I taken all the counting based logical questions only. Am I clear? They are good candidates for GATE point of view. Thank you, sir. See, this is little involved problem. You want to try? Options are there, you can make a try, but MCQ, don't take risk. Okay. How many paths of length 4 are there in a complete graph case 7? See, my dear friend, any path must be between two vertices. Any path must be between two vertices. So first select two vertices. Out of 7, select two vertices. Select two vertices between which you want to create a path. Select two vertices. Once you select it, how many more vertices are remaining? 5 vertices are there. You want path of length 4 means? Path of length 4 means how many vertices must be involved? Okay. Suprajit, very good. Good attempt. Nice way you tried. Good. But there is a small mistake in that. Let us complete that. Okay. Good. See, path of length 4 should involve 5 vertices. 2 vertices are already involved. So from remaining 5 vertices, you have to select 3 vertices. Not only select them, the arrangement should be done. That point I think you missed, Mr. Subrajit Pal. Now look here. See, what is done here is, okay, Deepyan, well done, well done. Let me complete it. See, suppose there is a path of length 3. If you select 3 vertices, path of length 4, this is one path you are going to get because it's a complete graph. All edges are possible. But this 1, 2, 3 can be arranged in 1, 2, 3 can be arranged in how many ways, sir? 1, 2, 3 can be arranged in 6 ways. So suppose if you are having 1, 3, 2, that will create one more path. Any arrangement of these fellows also will create a path. So from remaining 5 vertices, you have to select 3 more vertices and arrange them, because from A, any arrangement to B will give you a path because all edges are there. So we need, because already 2 vertices are selected, we need to select 3 more vertices from remaining 5 vertices, but we just don't want the selection of them, we want arrangement of them. Yeah, Ravi Gaming, so we want arrangement of them. 5p3 you have to do it, that is 7 into 6 by 2, because 5 factorial cancel. Here 5p3 is nothing but 5 factorial by 5 minus 3, that is 5 minus 3 factorial is 2 factorial. So it is 1 by 2 into 7 into 6. Here it is 2 factorial, that is 5 into 4 into 3. So this would be the answer, which is 1260. So C is the correct answer. Is it a good question? Very good. And you can generalize this. You can generalize this, sir. Generalize this. Number of paths of length K in complete graph K7. Complete graph K7. Of course, it with labeled vertices. Am I clear? With labeled vertices. Am I clear? With labeled vertices. The labelings are very important here. With the labeled vertices. Am I clear? So that is given by, first you are going to select, sorry, Kn you can take, Kn. So first you select two vertices, because between every two vertices path may be there, no? So select the two vertices between which you want to create the path of length k. So from remaining n minus 2, arrange that, because already 2 are there, because total k plus 1 vertices are required, 2 are gone, k minus 1 need to be selected. That would be the answer, my dear friends, which is n into n minus 1 by 2, and this is n minus 2 factorial by n minus 2 minus k plus 1, that is n minus k plus 1 factorial, which is nothing but n into n minus 1 into n minus 2, and it can go up to n minus k, my dear friends, into 1 by 2. So that generalizations can be done. That generalizations can be done. Hope you understand. Even I think here labeled should be used. Otherwise, if labels are not there, then the path identification would be, without labels, the path identification would be difficult. So it should be labeled one. It should be labeled one, my dear friends. See, this always, this labeling create lot of trouble. Remember that. Okay. Next one, 10th question. Two more questions to go, sir. Just two more questions to complete today's session. See, Deepak, it depends. It depends on complexity of paper may change. See, sometimes in one subject the complexity may be more, some other subject complexity may be less. It would be distributed, sir. See, the generally there will be definitely easy questions, moderate questions, and complexity, more complex questions will be there. Anytime it would be like this. Okay, for example, this is a very easy question, whereas the previous one is easy if you know it. If you don't know it, is tough. It's like that. People could able to answer that. At least they are able to attempt 2520. They are all good answers. 840, they tried it. That is all good. Am I clear? So the moderate kind of things, it depends on some subjects, which areas they select it. See, there are some areas most of the people generally only avoid or just go through and complete them. In such cases, obviously things would be difficult for them. Am I clear? It depends on the paper also. Sometimes some subject you find more tough questions or complex questions, we say. See, generally everything we say moderate only. Am I clear? To be very safe side. See, it would be like student point of view, there will be some tough questions, there will be some moderate questions, there will be some easy questions. GATE is generally mixture of all that, and sometimes overall paper may be very easy. In such cases marks will be very more, marks will be more, like up to 90, 95 also students get. If the paper is moderate, students may get up to 80 to 90, and if it is very easy, as I told you, 95. When it is tough, student also get sometimes 60, 70 marks only as the highest marks. It all possible, my dear friend. So don't worry about it. See, don't expect anything. That's what I'm telling you, Deepak Prasad. Stop expecting. Everything is possible. Just go for it. You prepared? Go for it. Okay. You may get completely different set of questions. Sometimes you know the concept, but the way it is asked is little different. So you have to carefully read the question. Okay, remember, just be open and go for the examination. Am I clear? Don't expect anything. Am I clear? Don't pray God, sir, dear God, please give questions from this topic. So God will give you questions from that topic, and remaining topic if he makes difficult for you. Okay, yes, you have to be. Am I clear? So don't ask God. He gives you something and something else he ignore, then it would be difficult for you. Am I clear? So ask God that keep your logical army or logical capability, okay, intact. Okay, you will not do any silly mistakes. Am I clear? Just pray for that and go for the examination. You can do much better than what you think. 420. It's a 420 question. Very good, sir. You know, number of Hamiltonian cycles in a labeled graph, in a complete graph labeled with n vertices. Number of Hamiltonian cycles in a labeled complete graph with n vertices is given by n minus 1 factorial by 2, and that is number of edge disjoint Hamiltonian cycle, number of edge disjoint Hamiltonian cycles. This is possible when n is odd. This is possible only when n is odd. When n is even, we don't have formula for this. This is given by n minus 1 by 2. Here n is 7, so 7 minus 1 factorial by 2, which is 360. And number of number of Hamiltonian cycles is y, sir. This is y. And this is 7 minus 1 by 2, yani 3. This is your x. He is asking what is y plus 20x. That is 360 plus 20 into 360, which is 420. See, sometimes these questions, yeah, very good, very good. Correct, 420 is the answer. The finale question, ready for finale, grand finale. And don't learn only the question, try to understand the logic behind the questions. Then many questions can be answered. I always see people learn this question only. If you change the 10 to 12, they cannot answer. That is bad thing. You practice this, you understand, try to do it with 12 vertices, try to do with 14 vertices. Once you can do that, you are ready for the examination. Suppose if 10 is changed to 12, if you cannot answer it, you are out of the league. Remember that. Good morning, Satyanarayana sir. And please follow the guidelines, dear students. Keep learning and keep growing. Good quotation. Thank you, sir. And last year similar question was asked, so we extended the idea to form a new question. G is a disconnected graph with 10 vertices and maximum edges. See, disconnected and having maximum edges when it is possible. Disconnected and having maximum edges when it is possible, sir. Last year GATE question it was. G is a disconnected graph with maximum number of edges. He asked what is that maximum number of edges. Same question modified a little bit. What is k is equal to 2? Yeah, k is equal to 2. Number of components is equal to 2. Very good. So number of components is equal to 2. Yes, yes. No need of guessing. Now this is not the time to guess. You are writing GATE examination, Subrajit. So it is time to fix things. It's correct. K9 and K1. When you do it, you will get maximum edges. Here, how many edges you are going to get? It's a complete graph with 9 vertices and it is a complete graph with 1 vertex. Here you get maximum edges. Maximum edges was the question. It was asked in last year GATE question. So it is NC2, that is 36 plus 1. 36 only, na? 9 means K9 is n into n minus 1 by 2, na? NC2. 9C2 is 36 only, na? 36 plus 0. 36 edges. 0 edges. 36 edges. That is about maximum edges. That was different question. But here you have to say chromatic number. What is chromatic number of this and what is matching number? We denote matching number by alpha dash. Chromatic number. Chromatic number of the graph and matching number of the graph. See, for K9, what is chromatic number, Babu? K9, what is the chromatic number? For K9, what is the chromatic number? For K9, what is the chromatic number? 9. For K1, chromatic number is 1. But one of these 9 colors can be used there. So no need of extra color for this. Use one of the 9 colors. Use one of the 9 colors of K9. Don't buy a new color. Okay, some rich people want to buy new colors. Don't do that. No need of any color. So chromatic number of the graph is 9. Chromatic number of the graph is 9 total. What about alpha dash? Right. Very good, Rami Gaming. But what about matching number? See, my dear friends. See, when it is a K9, you need to find matching number means maximum number of non-adjacent edges. Maximum number of non-adjacent edges. But here, finding beta dash is very simple. That is, beta dash is edge covering number. Now, when it is a complete graph with 9 vertices, you select any 2 vertices. Okay, you select any one edge. Sorry, you select any one edge which connect 2 vertices. Again, select any other edge which connect 2 other vertices. Any other edge which connect any 2 other vertices. Any other edge which connects any 2 other vertices. See, with 4 edges, I can cover 8 vertices. And I have to cover one more vertex. Total 9 vertices are there. To cover that vertex, I need one more edge. So here beta dash is simple. But you know alpha dash plus beta dash is equal to 9. Because beta dash is 5, alpha dash will be 4, my dear friends. That is matching number for this will be 4. For K1, there are no edges, matching number will be 0. So 4 plus 0 is the matching number. That is, matching number is 4, chromatic number is 9. So what he asks, matching number plus chromatic number, 9 plus 4, that is 13, my dear friends. So the answer for this is 13. Answer for this is 13, my dear friends. Hope you understand. Okay. See, my dear friends, Ravi, see this. Here I have 10 vertices in the graph and I want maximum edges. When I can get maximum edges, sir? When you have one complete graph with 9 and one complete graph with 1 vertices. This does not contain any edges, 0 edges here. In K9, how many edges are there? 9C2 edges. K9 means complete graph with 9 vertices. 9C2 means 36 edges. So total 36 plus 0 is 36. So this would be the maximum edges in a disconnected graph with 10 vertices. Maximum edges in disconnected graph with 10 vertices. Is the idea clear? Is the idea clear, Ravi Babu? Can you tell me about, suppose the graph is having 9 vertices. Can you answer this question? If the graph is having 9 vertices, can you answer this chromatic number plus alpha dash? Can you answer this? Same story. Disconnected graph with maximum number of edges. Try this before leaving. Yeah, at 12:30 I think you are having this particular workshop by Rakesh Talreja sir in Byjus Exam Prep app, Golden Rules. You can attend that immediately after this. Yeah, 28 will be edges because here it is K8, K1. 8 means 8C2. 8C2 means 8 into 7 by 2, 28 plus 1, 28 plus 0. 28 will be edges. But here chromatic number would be 8 because 8 and the chromatic number of the other fellow is 0. Alpha dash will be 4 only because beta dash 4 means alpha dash is 4. So the answer for this would be 12, my dear friends. So you can try with different graphs with the same idea. Number of vertices you keep on changing and try this. You can try with different. Yes, yes. You can keep on changing the numbers and try this problem, my dear friends. So that is the story. And my dear friends, on 4th Feb after your GATE examination from 1 p.m. onwards will be available on this YouTube channel. Will be coming up with this exam analysis. It is live from 1 p.m. onwards. So whatever questions were asked, of course it is based on memory based questions. Am I clear? But at least we can understand the difficulty level. See, as someone asked, na, sir, is it moderate? So after coming out, at least if you understand, okay, it was a difficult one or it was a moderate. Generally, people say. So we just mention based on the information we got. Based on that, we'll give you some analysis. Am I clear? Mostly, most of the questions will get it, and we make some analysis, and you can understand moderate means expected cutoff and everything. We can inform you at that particular time. So you also can understand how you performed in the examination. Am I clear? So this is live for computer science students on 4th February from 1 p.m. onwards. Okay, immediately after your examination. And you also have this particular, thank you very much sir, thank you very much. And you have this particular test series. I think one particular series is going on up to 30th. Please do write the test series to understand your mistakes, my dear friends. That's all for today. Thank you very much. And tomorrow at 11, starting from 10 a.m., we are coming up with this top 111 questions of GA, General Aptitude and Mathematics. Myself, Ankit sir, Rakesh Talreja sir and Ashutosh Saxena sir. So we four are coming with this particular session which starts from 10 a.m. Okay. So each faculty will be taking around 1/4 of the questions, my dear friends. So you can attend that particular questions to similar type of, important top 111 questions of general aptitude and mathematics. So that's all for today. Thank you. Keep rocking. If you have any doubts, you can ask me. Otherwise, I'm stopping the stream.